Hi, my name is Mark Reyna, and I'm a mechanical engineering postbac student with UTSA's Hypersonic Lab. And today I'm going to talk about the challenges of particle image velocimetry seeding in hypersonic fluid characterization. Particle image velocimetry, or PIV, is a powerful tool used in fluid mechanics to characterize and visualize velocities of particles in fluid in 2 and 3 dimensions. PIV is a tool that allows researchers to obtain information about a fluid flow, measuring disturbances, turbulence, quantifying flow fields, and studying behavior of fluids as they interact with complex shapes. In essence, it allows us to see what's happening with the fluid as it moves through a specified area of interest. In this photo here, you can actually see what 2D PIV looks like. This is a representation of vortices forming around an oscillating plate. So in this image, you can actually see the red colors are high speeds versus the green, yellow, and blue are lower speeds, whereas the black is typically not moving. The vital components of PIV include a particle seeding mechanism, a laser source, a high-speed camera, and image processing software. The seeding mechanism introduces particles into the flow. The laser source illuminates those particles so they can be seen by the high-speed cameras. The high-speed cameras capture the images of particles as they move about, and those images are then fed to the image processing software that identify the particles and calculate their displacement and velocity between each image. So the image that you see at the top shows a typical setup for a 2D PIV system. The black dot represents the camera. The rectangle at the top is the laser, and you could actually see the time differentiation between T and T prime. Despite its usefulness, PIV is not perfect, and the results can depend greatly on different elements of the setup. So the seeding mechanism must be carefully calibrated to ensure that the particles are uniformly distributed in the fluid flow. The particles must be small enough to follow the flow without disturbing the fluid, but large enough to be seen by the cameras. In some hypersonic fluid flow applications, one even has to consider the characteristics of the seeded particle at high velocity and the temperatures and conditions present in a hypersonic wind tunnel. It's for risk of the particle melting or changing state under certain conditions. And any miscalculation during the setup can cause the particles to follow erratic trajectories, cause errors or inaccuracies in the velocity measurements, and make it difficult or impossible to accurately measure the velocity of the flow. Despite these challenges, PIV have many practical applications for researchers and engineers. The vehicle that you see here is a real vehicle that will someday take flight. It is called the Hermes quarter-horse hypersonic test vehicle. PIV can be used to measure the velocity field around a vehicle or model in hypersonic flow, provide detailed information on the flow separation, shock waves, or other aerodynamic features. It has applications for flow control, combustion studies, the validation of numerical models, and can be used to study the effectiveness of and develop other types of flow control methods.